Hello! In this video, I, Zakaria, will explain about the main sequence star. What exactly is a main sequence star? A main sequence star is any star that is fusing hydrogen in its core. It is also in hydrostatic equilibrium. It has a stable of outward pressure from core nuclear fission and gravitational forces pushing inward. Stars spend about 90% of their lifetime being a main sequence star. An example of a main sequence star is our Sun. Categories of main sequence star. Stars in main sequence can be classified into 7 categories, which are O, B, A, F, G, K, and M. Each category are classified according to their properties, which are temperature, luminosity, mass, color, size, and lifetime. Main sequence O star is the most massive and the brightest, while main sequence M star is the least massive and the dimmest. In this picture, it shows how the properties are related to the classification. For example, an O and B type star are more massive and brighter than that in the G, K, and M type, which are least massive and the dimmest. While in the middle section here, F-type is in between the most massive and the least massive, and the luminosity is not too bright and not too dim. Next is wind displacement law. Wind displacement law states that the higher the temperature, the lower the wavelength, for which the radiation curve reaches its maximum. What this means is that hotter stars emit bluer color because blue color has short wavelength, and cooler stars emit redder color because red color has longer wavelength. The more massive a star is, the higher the luminosity, or brighter. This is due to the more hydrogen or fuel it burns. Hotter stars are bluer and cooler stars are redder, due to the difference of wavelength the star emits, as explained from the previous slide. We can assess the temperature of a star based on the color it emits, in which blue color has high temperature and red color has lower temperature. Larger stars live about 100 million years, while smaller stars live up to 100 billion years. This is because larger stars burn its fuel faster than smaller stars. Hertzsprung-Russell diagram. Hertzsprung-Russell diagram, or HR diagram, shows the luminosity and the temperature of the stars. For instance, we have the temperature on the x-axis, which we have blue or hotter to the left and red or cooler to the right. And we have luminosity on the y-axis, which the high luminosity is to the top and lower luminosity is on the bottom. We can see on top left, it has blue color and high temperature, which is the O-type star, whereas on the bottom right, we have red color and lower temperature, which is the M-type star. We can also see in this diagram that the main sequence made a diagonal line, hence the name main sequence. It is not the lifetime sequence of a star, it is rather the sequence of stars going from upper left to the lower right according to their types or categories. Red giant. As star gets older and running out of hydrogen or fuel, the hydrogen of a massive star runs out, the star begins to use hydrogen further out from its core. Hence, the star will expand, increasing the surface area of the star, resulting to high luminosity. The star also cools down due to the spreading of it, giving the star a redder color. White dwarf. After billions of years, the red giant will turn into a white dwarf. After the burning out of hydrogen, the red giant phase of the star will move to the next phase, which is the white dwarf. The red giant star will contract into an Earth-sized star, and as it contracts, the core heats up, which results to white dwarf having bluer color and has low luminosity due to the less surface area. These are the links for our reference materials. You can find these in the description below. And that's all for me. Thank you for watching.